And we talk about the polar equations. And suppose we have the position vector in a rectangular plane, and the terminal point of this position vector, say this is the A and B, and the direction angle is theta. We can also get the magnitude. Okay, let me call this vector V, right? The magnitude of this V is like this. So now we know we can also relate this to the A plus BI, right? Actually, this vector and this A plus BI just stand for the same point on this plane. So now, with one angle and one number, the magnitude of this vector V, we can determine one point on this plane, right? So we have the one number, that is the modulus of this vector V, and the one angle theta, which is the direction angle of this vector, can locate one point in the plane. So before we use the two numbers, right, x coordinate and y coordinate, to locate one point on the plane. So right now we just use the one number and the one angle. So we replace one number by an angle to locate one point in this plane. So now, suppose in a plane we have a fixed point, and this fixed point is called the pole. And then we have a fixed ray, and this fixed ray is called the polar axis. So this polar axis is a fixed ray. Now, to locate one point, we need one number and one angle. So we put them together to form an odd pair. So that is the r and theta. For example, you have the one point here. It has the r and theta. And this r and theta is called the polar coordinates of the point P. Suppose this is the point P. And let's first say a few words about this R. this r is the directed distance from this point P to this pole. And you may just identify pole as the origin of the rectangular plane. Actually, generally, we like to combine these two together. So we may also draw a rectangular coordinates imposed on this polar system. So let me use another color. So this y-axis, and generally the x-axis, the positive x-axis, just coincides with the polar axis. So this r is the directed distance from this point P to this pole, to this origin. So this r is here. And it's called the directed distance, right? Let me call this pole O. So directed distance from P to O. And since it's directed distance, so it can be positive or negative. Okay. And theta, this guy, is the angle whose initial side is the polar axis and the terminal side is the ray going through the point P. So the theta is formed by this polar axis and one ray going through the point P. So if r is positive, then this point P is r units away from this pole, okay, on the terminal side going through this point P, on the terminal side of this angle theta. And if r is negative, then this P is point P is the absolute value of r units away from the pole on the terminal side but in the direction opposite to the point with the polar coordinates, the absolute value of r and the theta. Now, let me give you some examples about the polar coordinates and see how we use all those polar coordinates to locate the points on this plane. So we first have the pole and then polar axis. For example, we need to locate the point with the 2 and pi over 4 as the polar coordinates. So first, we draw the angle pi over 4. Okay, draw its terminal side. Right, this is the pi over 4. And then we locate one point which is 2 units away from the pole. So it's here. So this is the 2 and the pi over 4.